For nearly 2,000 years, waves have crashed against ancient Roman harbors. Earthquakes have shaken old structures. Storms have battered coastlines. And yet, some Roman concrete is still standing. Meanwhile, plenty of modern concrete begins showing cracks after only a few decades. That raises an incredible question. Did the Romans know something we've forgotten, or is this one of history's biggest engineering myths? I wasn't interested in internet legends or exaggerated headlines. I wanted to find out what modern science actually says about Roman concrete, and whether the basic principles behind it still work today. The answer turned out to be far more fascinating than I expected. When people hear Roman concrete, they often imagine a magical recipe that disappeared with the Roman Empire. Some claim it was stronger than anything we can make today. Others believe we've completely lost the secret. But reality is much more interesting. Modern engineers understand many of the ingredients the Romans used. Historical records and scientific studies suggest that Roman builders commonly mixed lime, volcanic ash known as pozzolana, water, and stone aggregates. In certain marine structures, this mixture interacted with seawater over long periods, allowing new minerals to form inside the concrete. But one way of looking what's being discovered is to raise the temperature from the side pillar. But that doesn't automatically mean every Roman building was indestructible. Many ancient structures have collapsed over time. Others required repairs. The survivors simply happen to be extraordinary examples of ancient engineering. So, instead of asking whether Roman concrete was magical, I decided to ask a better question. Would the basic principles behind it still make sense today? To explore that question, I gathered information from historical sources and modern materials research. I wasn't trying to perfectly recreate an ancient Roman recipe. No one can say with complete certainty that we've recovered every exact proportion or construction method used 2,000 years ago. Instead, I wanted to understand why this material performed so well in certain environments. One detail appeared again and again: volcanic ash. Not just any ash, natural volcanic material rich in reactive minerals. When combined with lime and water, it can create a durable cement-like binder. This reaction is still well understood today. In fact, modern engineers often use pozzolanic materials to improve concrete performance. That immediately challenged one common myth. Roman concrete isn't mysterious because it ignored science. It's impressive because the Romans learned through observation which natural materials worked well together. And this is where things became interesting. Modern concrete is designed for different priorities. We build quickly. We need predictable performance. We manufacture billions of tons every year. Roman builders worked more slowly using locally available materials. The goals weren't always the same, so comparing them isn't as simple as asking which one is stronger. Instead, it's about understanding why each material excels in different situations. Some researchers have also studied small white lime fragments found inside ancient Roman concrete. These pieces were once thought to be mistakes. Now, some scientists believe they may have helped the material repair tiny cracks over time under certain conditions. It's an exciting area of research. But it's important to remember that scientists are still investigating exactly how these processes worked and how significant they were. That doesn't make Roman concrete less impressive. If anything, it makes the story even more fascinating. Because we're still learning from builders who lived 2,000 years ago. But then another question came to mind. If modern science understands these materials, why don't we build everything this way today? The answer isn't because the recipe stopped working. It's because construction has changed dramatically. Modern buildings often require fast curing, standardized materials, reinforced steel, and strict engineering specifications. Roman-style materials may offer advantages in some applications, but they aren't automatically the best solution for every project. Engineering is always about choosing the right material for the right job. That realization completely changed my perspective. Instead of seeing Roman concrete as a forgotten miracle, I started seeing it as an early example of remarkably intelligent engineering. The Romans didn't have laboratories or computer simulations. They relied on experience, observation, and generations of practical knowledge. And somehow, they created structures that continue to inspire researchers today. That doesn't mean modern concrete is inferior. Today's materials make skyscrapers, bridges, tunnels, and massive infrastructure possible in ways the world never imagined. The Romans didn't have peak, but ancient Roman builders solved different challenges with incredible creativity, and that's worth appreciating. So, does the ancient Roman cement recipe still work today? In many ways, yes. The underlying chemistry behind lime and pozzolanic materials remains well understood and continues to influence modern construction. However, that doesn't mean we can perfectly recreate every ancient structure or claim Roman concrete is universally better than modern concrete. The reality is much more balanced. Roman engineering succeeded because builders carefully matched available materials to their environment. Modern engineers do exactly the same thing using today's technology. Perhaps the biggest lesson isn't that ancient builders were smarter than modern scientists. It's that great engineering ideas can survive for thousands of years. Sometimes history doesn't become obsolete. Sometimes it becomes the foundation for future discoveries. That's why researchers continue studying Roman concrete today, not because they're chasing myths, because they're searching for practical ideas that could help create longer-lasting, more sustainable building materials. And that's a goal that matters just as much now as it did 2,000 years ago. The next time you walk past an old stone structure or see pictures of ancient Roman harbors still standing against the sea, remember this: you're not looking at magic. You're looking at centuries of observation, experimentation, and remarkable craftsmanship. History didn't leave us a miracle recipe, it left us questions. And sometimes asking the right questions is the first step toward the next great innovation. If you enjoy exploring the real science behind ancient technologies and separating fact from fiction, there are many more historical mysteries worth investigating. Because the past still has plenty to teach us if we're willing to look beyond the myths.